Today's notes are on compound interest and exponential decay. The equation for compound interest is A equals P times the quantity of 1 plus R over N raised to the power of NT. In this equation, P is your initial amount, R is your interest rate expressed as a decimal, T is the years past, N is the number of times interest is compounded per year, and A is the total value after the years have passed. In these problems, for when trying to figure out what N equals, if something says that it is compounded monthly, that means it has been compounded 12 times a year. If it says it's compounded daily, it'll be compounded 365 times per year. Quarterly is equal to 4 times per year. Annually is once a year, and semi-annually is twice a year. We're going to start with example 1 by identifying each parts of the equation. So we'll need to identify P, R, N, and T. A customer purchases a television set for $800 using a credit card. That is our initial amount. The interest is charged on any unpaid balance at the rate of 18% per year compounded monthly. 18% as a decimal is 0.18, and it's compounded monthly, which means it's compounded 12 times. If the customer makes no payments for 1 year, how much is owed at the end of the year? So our number of years, which is T, is equal to 1. We are going to plug these values into our equation. So we get A is equal to 800 times the quantity of 1 plus 0.18 divided by 12 raised to a power of 12 times 1. If you're entering this in your calculator, you'll want to make sure you put parentheses around the fraction as well as your exponent. Typing it in, you should get 956.49. We're going to round to the nearest hundredth because we're talking about money. Next, we're going to look at example number 2. We're going to start the same way, identifying the variables in the equation. You deposit $1,000 in an account earning 2.5% interest. So as a decimal, this is 0.025. Find the balance after 3 years if the interest is compounded daily. So I have A equals 1,000 times the quantity of 1 plus 0.025 over 365 raised to a power of 365 times 3. Again, using your calculator, put parentheses around the fraction and around our exponent. You should get an amount of $1,077.88. We are going to look at the steps for graphing exponential decay functions in class. For modeling exponential decay with applications, we are going to be using this simple exponential decay model. Y equals A times the quantity of 1 minus R raised to the power of T, where A is your initial amount, R is the percent increase expressed as a decimal, and T is the years passed, where Y is going to be your total value after the years have passed. 1 minus R is your decay factor in this model. So for example 5, it says you buy a car for $25,000. It decreases in value by 20.5% each year. What is the value of the car after 10 years? I'm going to start by identifying the values of A, R, and T, so I can plug them into the equation. My initial amount was $25,000. My rate is 20.5%, which is 0.205 written as a decimal. And I want to know how much it would cost after 10 years. So we get Y is equal to 25,000 times 1 minus 0.205 raised to the power of 10. You can plug this whole thing into your calculator, or you might choose to simplify inside the parentheses first to get 0.795. When you type the whole thing in your calculator, you should get a final amount of $2,521.22. Again, because we're talking about money, you're going to round to the nearest hundredth. See if you can do example 6 on your own. We will talk about it in class.